Hello. In this video, I'm going to show you chapter 2 of the direct way to Linux Ubuntu programming or operating system in this case. So you will learn how to use Linux Ubuntu. And this is a book that I wrote and it's available on the internet for free. It is on MyWebUniversity.com website. So let me share my screen first, and then we will just go through the book and then coverage everything. So if I could just go to the MyWebUniversity.com website, which is right here, MyWebUniversity.com website. And this is the title of the book is The Direct Way to Linux Ubuntu, which teaches you how to use Linux Ubuntu without being on that operating system, install an operating system like Linux, Ubuntu, or any other operating system. So all you need is a browser, like I have a browser and access to the internet. You can use your favorite device. In this case, I'm using my laptop to connect to my Web University URL, and I'm ready to just learn. So in this case, if you go to the main page, and then there's a button here that you could right click on it, and it can give you the table of contents. So in this chapter, in this session, I'm going to teach you or mentor you how to use the chapter 2 basic Unix commands. So if you click on this, and the interactivity is all available using your browser. You don't have to install the Linux operating system, or you don't have to do anything on your side. You just use a browser as a client, and then make sure that you have internet access. Then you come in and start learning. So if you visit the mywebuniversity.com website, and you go to chapter 2, for example, on chapter 2, I have 3 steps for you to learn. Step 1 is giving you the what is command list, and then for each of these commands, there would be a what is command. And then as you see the command, there's a man page for it. So you can see the manual Unix manual pages. And then I'm also giving you examples. As an example, if I just click on this banner, it goes to a banner page automatically, and then it says, what is banner? And it just says makes posters. Basically, banner is just giving you posters, not posters, posters. And so it makes you display posters. And then right here, as you can see, I wrote like peace for all, and then it is written in the same way. As if I just do hello world, it's hello world is displayed. And here I just say I love to play football. And then whatever in front of the banner as a string, I pass it on right here, that will be displayed in a poster format. So here I'm giving more examples of like if you see the web, you can just print an A. Whatever character or a string that you want, it will display. And then also here on the manual pages, if you click, there's manual pages for the banner. For banner, and because it is just a simple poster display, there's not much argument or anything, so you just put the banner and text. And just coming back to the page here, if you do the same thing with calendar, you could get a list of options. What is the calendar? Display a calendar of the month or calendar of the year, depending on the argument. If you don't give any argument, like you click on cal, this is almost as if you're sitting on a Windows machine on a browser and you use it executing the Linux commands. The commands output will be, this command will be running on my Linux Ubuntu server at mywebuniversity.com, and then the output will display here. So when you click on the calendar, it displays the current month, which is in this case, November 2021. When you run it, it will just be whatever month that you run it on. And then here, this one is specific to calendar of 9031. So it displayed the 9031. And similarly, if you look at the calendar of Epoch, the Unix calendar started from the Epoch calendars, 1970s. So the January 1st is the Epoch calendar. Unix was invented by Ken Thompson and Dennis Ritchie at Bell Laboratory of AT&T back in 1969 through 71. They start writing this, and then on the preface on the chapter 1, I'm actually pointing out to their pictures and everything. So we will go through the chapter 1 on another day. But right now I'm showing you the commands on chapter 2, which is basic Unix commands. And then there's chapter 3, which is intermediate commands, and chapter 4 is advanced commands. So I'll walk you through each chapters, and that way you can understand it. And the same thing, man calendar. Notice that this one, for the calendar, you will have more output here, more information there. And there's also section of man pages. Whenever you learn one command, you can get another command from it by doing man pages on that one as well. And then, like, if I just look at the February 2nd, February 1998, and you can see that that is just displayed for that one. Similarly, for, let's say, June 6th, I mean, June is the 6th month, if you want to get the 6th month. And I'm going to also show you another method of this. So this information is all together and there available for you. And all you have to do is, like, sometimes, like, if I just want to run the cat command, I just give you the output here to display it. But let me walk you through, since I'm just making a video, I also wrote a PDF version of this book, which is going to be available also. The PDF version of the book is basically, it says the direct way to Linux Ubuntu, and it's gonna just display the banner, the information. God bless my brother. This is about him basically helping me in life so much. He was a noble person as a cardiologist working at Kaiser for many years. He inspired many people's life. He was the great inspiration for my family, my sibling, for friends, relatives, everyone. So I'm dedicating this book for him, and I know that he's in best place in heaven, and his legacy will live in us forever. So right here, if I just show you the preface in chapter 1, chapter 2, each one of them is also clickable on the PDF file, so you can actually go to the website. But then on chapter 2, if I go to chapter 2 here, and you can see chapter 2 has all the information. But what I want to do is for chapter 2, like here, I'm showing you a little bit more on chapter 2 on this PDF file. So I'm going to just give you more examples actually using a terminal console. For security purposes, I cannot just show you everything on Linux environment, because the reason is that some commands require root privilege or sudo access or higher privilege than just a web interface. And for security purpose, we can't do that. Some commands requires you to just add another user on the system or delete something, and I don't want to do that one on my website. So for those reasons, I had to written my program. I had to write my program for a specific reason, to just make sure that it does all these commands and everything for you, and give you as a student or as a person that love to work in the Linux Unix environment and want to learn. And this is just another kind of cookie for you that you could just have. So let me just go back to the chapter 2 of the book here. So if I just start with banner here, let me just show you, you can just already running these commands there, but at the same time, I could just log into a Linux server. Let's say I'm gonna go to my directory. Let me just exit out of the root first. So right here, I'm going to clear my screen. If I do PWD, which stands for print working directory. So now I told you that the banner will show you that prints larger banner or posters. So in this case, if you just type any text in front of the banner command, it will just display. For example, say banner, I love to. You could put it in code because there's the spaces here, but to play football, this is long string, and then in that case, if you do that one, you notice that the love to play football, it just trimmed out. So some of the string, if you say I love football, you could just see the last thing. It is just a matter of the kind of, let me just open up another terminal that is not X session. So if I just do this one and I say banner, I love to play football, and you can see the whole thing because I'm not using, depending on your terminal console, you will have a different output. The other one that I was using an X session, so this one I'm not. So now you say, I love to play football, and it is just horizontally played the words for all of them. But if you just write a small letter, like you say, banner peace for all, you can see that it is just there, peace for all, and peace for all. And then again, the trimming is happening because of the console's setting here. So I have to change the resolution, everything, in order to play around. Or I could just use a smaller text here. Just say banner is for all. And then you see that when you don't put it within code, it just puts it in horizontally. So the syntax that if you want to write longer words, say, welcome to MyWebUniversity.com. If you do that one, it's still welcome to my web uni, and then after that one, I just trim it out. Because a banner usually have a limit of, depending on what canvas or what kind of terminal you're displaying that information. So the display is for the wording, the fonts that you use is different. And then that's why you could just limit yourself to say, for example, if I just say banner, I love to play football. And then you can see that even with this, since I didn't double code it, it put each word separately. And by doing this, like this, you can see that the banner thinks that this is one argument, this is a second argument, and this is third argument. So normally in a programming languages, like if this one is my program banner, this is argv sub 0, this is argv sub 1, this is argv sub 2, and up to the last argument. And that's how those ones are passed on into character strings. So on some other video, I'm teaching C++ at the same time, and on those ones or Python, I'll show you how those arguments are passed on into programs. And so each program has the name of the program and then the parameters that you pass on. So in this case, let's just do another command here, like calendar. So if I just do the calendar here, I could get those output, which we already tried it, but at the same time, let's just get the commands for calendar. We could just say calendar here, and that is the current command. If I get it in Julian format, then I could get it like that. And if I just want to say, clear the screen, let's say I want to do a cal for 19070. like the one that we did in there. So that's January 17th. And the calendar, you can go as far as you want. Like if you just say, let's go to 1900, and then you could just get a calendar of that one. And if you want the first month of it, you get that. If I just want to get the epoch calendars 1970, that's January 1st of 1970, then it will display. And you can get the calendar of anything, like let's say even go to 1700 there. And if you wanted the January 1st of it, you could just go as far as you want to, maybe to, let's say 0002. Yeah, you could even get like the first of it, and you could just get calendars for it. And then that you can also get the calendar with the option of J for Julian format. So that's for the month. If you want it for the entire year, or you can do 2021, let's say. And if you want some, like when is the next year, 2022, January 1st is what day, you can just say January, and then you can see it is falling on a Saturday, January 1st. So you can also get a calendar, like for example, this month is November, you can get a calendar of, let's say the dash B for before, and then you can say 3 months. So you can say, this is November, and show me 3 months before that one. Or you can say, show me 5 months before that. Or the entire 12 months you could get from this month, and you just get that. Or you could just say, show me after. So this is the next 2 months. So November is the current month, and January, December, and January is the next 2 months. If you want the next 5 months, yeah, you can just print it -5. So that is the calendar command. It just basically help you to do this. The same kind of options is with the Julian format. So if you just want to display in Julian format, you could do it that way too. And then if I just put -J here with the format, notice that these two are showing in Julian format, and then the next 2 months is showing in regular format. So I'm going to just do a man on calendar. You can see the output. There's a lot of options here. You can just display whatever information that you want, and then like date of Eastern and so on, Julian, and other options that are there. And just all you have to do is get into a terminal, type in the commands. Let's go to the next command, which is cat command. Cat command is the what is section shows you that it concatenates and prints on the standard output. So on cat command, as you can see, I'm giving some information here that you can run, but I have to show you a lot more than that one, just to concatenate a file with line numbers or something, or no line numbers. So here I'm doing like cat -n, and then the actual command you're running is here, and the output is displayed here from the server that I'm running on. But you're not tied only to those two commands. So let me just open up here this one, and we will go through the cat command here. So if I just want to say cat etc host file, you can see the host file that has that information. If I want to just see the content of it with line number, I could put the same thing with -n, and it will say there that line number. I can also say cat etc host and then word count -l, and it says that is 14 line there. That's why this is accurate. So I could just also cat the file, like for example, os-release. If I just want to see the content of my server and running Linux Mint, 19.3, and that's not the latest version, but the latest version of Linux is 20, but it is still good. It is secure enough. So let's just look at this one and then put -E for the option, and then to show everything and with end of line as $sign. So you can see that wherever the line is, the end of line has a $sign at the end of it. Everywhere, and that means there's an end of file. So if I just do -A at the same time, any control characters that are there with tabs and everything, and this file does not have anything. Let's just look into another file. Here, I'm going to look at the words.c++. So if I say cat -n words.c++, notice the content of this file is showing 36 line. It's a word.c++ program that basically count the number of words, similar to wc-w command. So this words.count, it will count the number of words. But what if I want to see in the same file, and instead of showing only the text file, I want to see all for including end of line. This all by itself, it shows you everything. You don't need E also. E is going to give you the the file end of line marker $sign. So if you do this, it covers everything all. So if I do this, and let me just do a pipe more, and that way we could see for each end of line, there's a $sign here that include IO stream and stuff or there. So these are new end of line characters and this and that. So if you could see that on this one right here, there's a tab. So there's a Control-I character as a tab in this case. If there was any other invisible character, you would see them here. But if you do it without the argument here, you don't see the new line characters right here because they're inside the file. So if I just go here and I use the vi command or vim command to display the content of it, and you can see here set, let me just go. Okay, somehow it is taking so long for the connection. Output is not displayed. Oh, sorry, the vim, the pipe more was not supposed to be there. When you VI it, you're supposed to just have one command. There's no pipe more anymore because we're opening it a vim editorial. So that explained why that was hanging there. /more was only for the cat command, and vim and does not require that one. So here I'm displaying it. Notice that if I say set and U for VI to just show line numbers, I can see the line numbers, but I don't still don't see the control characters or invisible characters. So here, if I just say set a list, and inside here I can see the control characters like new line characters, and then right here is a tab. So if I just go press another tab here and just tab, every time I press a tab, it just shows that that is Control-I. So now I put two of them. I'm not gonna save it. If I save it and I have the privilege to write it, now I just updated it there. So let's do a cat -A again, words.c++ and 5 more. And you can see there's two tabs now here because I pressed tab. And I could also verify this command with octal dump od -c. Octal dump display the octal dump of the file in a kind of text format, -c meaning the character, -x is hexadecimal. So in this case, every new line, the $sign that was showing on the shell as a $, they're actually new line characters, /ln or /ln is just new line, /lt is tab. So everywhere that was Control-I, it is showing as LT right here, tab. When you're writing a printf statement or cout statement in C or C++, then basically you're using the /t for tab, /ln for new line, and /a for alarm, and so on. So let's go back to the cat command. I'm going to display one more options for the cat. Cat, also you can use cat command to echo stuff. So I could say cat, and then let's say this one I could put anything, say doc for documentation or something. So when I put this doc, that whatever word that I use here, the rest of them I have to issue the same command. So if I say pwd, and then I say who, and then ls-l, and then just say doc again. Now, those ones were displayed as output here. Whatever I typed in, it just catted back there. If I want to send that information to the a file, I could say cat, and then this, remember this file, I just said I can just write anything to it. So let me just write a program and execute that program using cat command as if I'm on a VI there. I'm going to write a shell script and there. So I'm going to say cat, let's just call this documentation part of it. So I can write it, I could just use even my name, Wahid. And then the output file, I'm going to say, let's say, script1.sh or .bash, whatever I want to do it. Let's call it .sh. So here I'm going to say pound /bin/bash, and then I just say, let's just execute a few commands here. pwd who date, those commands, and then let's just do calendar as well. So those commands, and then now I have to terminate my script, Wahid. And now I have a script called script1.sh. Notice the permissions of this script is not executable. That means I have to either do run bash -x to run it with -x means run it in debug mode. So I could say, yeah, the command ran successfully and it's there. So when you do -x, it just shows you the command and then the output with the plus in front of it and then the output. So for calendar, there's command calendar and then this. But if I just do change mode 755 script1.sh, and then I do ls-ld script1.sh, notice that the color changed and also the file name is showing read, write, execute for the owner, read and execute for the group. In this case, owner and group is wlutfi, and then read and execute for other people, the rest of the word. So in this case, if I type in ID, my user ID is wlutfi, my group ID is wlutfi. So I made the permission to say I can read and write from this file, and then to read from this file and write to this file and also execute it. So what do I mean by execute it? I can run it like this, / because Unix is with root as the path, it's not the backward / like DOS, it's the /. So you run it, and then this time you don't see the dash, the command, it just sees the output. This is the output of pwd. This is the output of the whatever command was there for, let's just, in order to look at it again, you can say cat -n script1.sh, and you can see the who command, who was logged on. Who -r also shows you the run level. So who by itself is there, W is giving you that information. But script1.sh, now if I just don't want to see line numbers or anything to it, I could do this. And you can also add to this command using cat command. So now if I just want to, I could use echo command to add to it. For example, let's say I want to add one more command called, let's say, who minus r. And who minus r, I could say echo who minus r for run level, and then double greater sign, then script one.sh. So this case, I'm just echoing this command into the end of this string. By this double greater sign, I just append to it. So now script one.sh has the command who minus r. If I just run a script one.sh, is there with a run level this. And then now let's just use another command. I could just say, let's say I want to just override this one with only another command like ls minus l or something. So let's just create another command, say, let's say ls minus l star.c++. And then we just send that one to a file called t. Now, contents of t is only that command. And if I just say cat t, only one greater sign to say script one.sh, now I just overrode that file with the thing. But if I want to do write that line multiple times, I could just say double greater signs. So every time I do double greater signs, that file is appended at the end of it. Notice the usage of greater sign with cat and appending and this. So you can also create multiple files out of this. So you can see the display of 3 files. So if I just do this and then I say greater sign and then a new file called f. Now word count minus l t script one.sh and f. If you can see that they're all different sizes because the f and t is the same, right? I'm sorry, f and t, f has one, t has 1 line, f has 3 lines, and then none of them are the same. And then script one.sh is this 2. So what if I just want to make a combination of different commands out of the cat? I could do that. And so I could say cat etc host and t and just those 2 files, send it to the file f. Now, and the f file has etc host plus the ls command. But they are unnecessary, so there's no needed there. You can also do cat command to execute something like right there. And then let's just do one more example of the cat command. I'm gonna just say cat t and greater sign a script. Let's just do a few commands. Echo pwd and then greater sign t.sh, and then I'm gonna just run a couple of commands, who, and then banner hello. So let's just try these things, and then so banner hello, and then the next command is pwd. The next command is calendar command, and that's it. So cat t.sh now has those commands. And then I could also use the cat command to put this one into an argument and read them. Here I could say cat t $sh, and then at the same time I could just execute these commands within a while read var. So I say while read a variable do, and then I say echo $var, and then that would display the command and then run the command after, and then done. So now you can see that I just did on the fly a command using cat by reading the contents of a file and display there for each of them. And if I just want to see the content of the command, the last command was pwd, which was the output was here and the banner was here. I printed out, and then the previous command was who, and it was there. And then calendar is also the last command here that displayed it. So with cat, a lot of different options you can do. And I'm on the book, I'm showing you how to compress certain information and everything. And then how to do a lot of different options there. If you need to check it out, cat is your friend, and you can see all these options. Dash A I showed you, dash number non-blank. So instead of dash n, you do the opposite of dash n, and this one override that dash n. Shows end of line and then numbers and then squeeze blanks. So if you have too many blanks spaces on a text, it will just reduce them there. And the same thing with the number of lines, that if you want to just get rid of the 2 lines or 3 lines. And on the actual book here, on the PDF files that you could get access to a PDF file. And then right here, basically this Word document for cat, I'm showing a lot more examples here. So the octal dump I showed you here, and then like the silent or suppress options and here. And then for each one of them, I did give you the definition of what -s for suppressing repeated empty output. And basically, if there's like too many empty lines, then it will just get rid of it. And then the -sn, n is give you the line number, but you see here that there was multiple lines, and then it was suppressed to 1 line. And that's why that information is going to do it. Without it, you see this have 2 lines. The 2 line changed to 1 line here, and because I'm using this -sn. Here, -e for end of line marker, and -a, you can see $sign here, and then the control characters that are there are showing as well. A space is just showing blank space. And then you could get the output as so. And then the man-cat command I showed you. And there's another technique that you can also, I'm showing here, that you can run actually the UNIX command without even running it. Notice that here I'm creating a doc, but then the output, you can just put it into a file, and then here within $sign, left parentheses, right parentheses, you can put any UNIX command. As long as they're valid Unix command, it will be executed. Like here, $sign date, and here's the echo statement. And then the backtick things is also a valid way to execute commands. Sometimes like you want to run a script to find something here, I'm showing you that. So let me just do one more technique here with the cat command. So what I could do is here, say cat, let me just clear the screen first, cat, and I could just say less than sign, double list. I could call it execute or exec, or doesn't matter. Whatever I name it here, I have to terminate my statement at the end of it. So let's just call it SS for a shell script. So I'm going to just say this and greater sign, and I'm going to just say s1.sh or .bash in this case. You can name it anything you want. So here I could just say some commands, say for example, the backtick is this symbol. I could say pwd and then backtick and say who. These commands will be executed right away as soon as it is done. And then the other thing that I could do is say $, and then say find a dot minus name. Let's say just minus type D for just only show me that directories. You could do that one. And then this thing is not braces, it's parentheses. So that's very important, $, and then the argument. And then here, I could just also say this, and then run the command, say ls minus ld, let's say the something.sh. Whatever the sh files are there, it should display it. I'm going to stop it there because we showed 2 examples of those. Let's just run another command also at the date with this, so we know that it runs today. So now I just need to finish it using this SS. So I'm going to say SS, and then that program finished. So now s1.bash is there, and notice that this one is not executable. I could have put even a change mode on this one to just change the permission of it, but it still wouldn't run because I have to still do -1.bash at least once to just do it. And notice that the command that was successful, it worked. This is a directory. So some of the commands, like this one shows the date command at the end, and then this one is the ls minus ld. Syntax is somehow this had to be put into, because it's wildcard, I could just put it here and say star.sh, it would understand. But if I'm just doing it within this $, it did not understand that one. So let's just do cat this ss and then just write again s1.bash. This time I'm just going to do the pwd worked. So sorry, the pwd worked right here, so I'm not going to test that one. The second command, it says the who, line 1 is there. Okay, let's just do the find the type. I'm going to try these couple of them in an argument. So I'm going to try only the one with the ls to make sure that that one for sure failed. So I'm going to say ls minus ld and then put this code around this .sh and see if this time it understands it. And then I'm going to say ss. Cannot access star.sh. So it already tried to do the command and it failed. So let's just do that and cat ss greater sign s1.bash. At this time, I'm going to say $, and then ls minus ld, and then single quote, and then star.sh. And then run the finish it, no such file or directory. So it does not find it. But let's just do with the backtick the same thing. And instead of this, I'm going to use the backtick. But the backtick and say ls minus ld star.sh. This is almost like run this command as it is on Unix command. So now it says, and then this one finished. So depending on the command, sometimes the backtick works, sometimes the $sign argument works. So the backtick, it just says run this command. Now cat minus ns1, there's only one line, and then the output is already there with whatever we wrote on the backtick. So the backtick got executed and the output was written here, which means that if I do this here and I just say backtick and then, sorry, let me just do cat less than sign ss and then greater sign s1.bash, and I just say backtick pwd and then run the date command. I'm just going to do this as a valid command and one line, no space is there. And then I'm going to also do the backtick, and then ls minus l star star.sh. And then at the same time, I could just do a change mode on the backtick. Oh, on the backtick, I forgot to put backtick. Let me just control C out of this. Cat ss and then greater sign s1.bash. So backtick pwd and then run the date command. Run the date command in here. Date. Okay. So now I'm going to do backtick. Backtick. ls minus l star.sh and just make this one ls minus ld. So backtick here again. Let's do another $sign calendar, and then I'm gonna do a backtick change mode, and then s1.755 s1.bash. So we change the permission as the command runs, and because this file gets created and then it does it. If the command does not get created, this file, then it would be a problem because these commands go in sequence. So by that time, the file has to exist. So we're going to do that and then do ss. So now s1.bash is there. Notice because I put this change mode 755, it changed the permission as well. So it made it executable. Now I can say s1.bash, cat s1.bash. It's actually a script output here. So the name should have been created like s1.bash.output or .text. So this is the output of the first command, pwd. This is the output of the second command, the date. This is the output of the ls minus ld, star.sh, and then this is the output of the calendar command. Notice that this time, because we put this in argument in backtick, it worked. But if you try a longer command with the find, it may run here, find.minus type d here, and it will just find out all the directory here. But if you say cat, let's try it one more time, less than sign ss, and then we say script2.sh, and then we just say $sign. I might have typed in without the dash option here. That might be the reason. Minus type d. Sometimes what I say, I might type, my fingers will do it correctly, and my wording might be a little bit in a hurry and say something different. Find out minus type d, and then now ss shell scripts. So you see that it worked. So s2.sh. On the previous example, that I might have just typed in without the dash here. This is just saying, show me all the files that are directories. So if I just want to do all regular files, -f, and that would display all the files that are regular. And if I just want to say minus name is star.c++, I could do a find command here. And then here I have to put an and, minus type is F and then dash A. So here I'm going to do it in multiple Boolean operators. So minus type is F. Minus type is F and minus name is C++. So this one is, that's why. And then here I have to skip it, and then here also skip it. Let's do this one simply, find dot minus name star.c++. This would give you all the C++, and then minus type F is automatically their type F already. So if I just say that show me files that are .sh, and then type is executable, dash type is, in this case is F, and then I do something exact, change mode, not change mode, ls minus ld, this, and to see the permissions of the files. Some of them were different permissions. So here I could also say, show me the one that are with certain permissions, and then with a certain ownership and certain groups. I'll actually cover the find command and details of those ones when we come to that chapter. Right now we're in the middle of the cat command. I want to not just move out of the topic here. Let's go back to the next command. So next command you're doing here is clear. Oh, this is a very simple command. So clear is just clears the screen. So if I'm just having this screen, you could say clear. You could get ls minus l and then say clear. Every time you type in clear, it just clears the screen. So and then you can also say like pwd ls minus l who and then you can just say tput clear. That also does the same thing as clear command. So tput clear or tput clear or just simply clear. They both will do that clear command. So if I just say calendar and then say tput clear, it is there. But you don't need the tput in front of it because tput has a lot of other functionality. One of them is just does the clear screen. You can change font and everything. I'll cover those ones in details as well. So let's go to the date command. Date commands are depending on what you use. Normally, when you do the date, if you look at the book, when I write the book, here on the date command, I'm just giving a lot more than just regular Unix commands. So let's see on the date command here. Date, yeah. So the date, as you can see, that the example I'm showing here, you have to be root in order to change the system date. But nowadays, you don't change the system date manually. You set up your time zone and then the date is automatically updated. But then you install the NTPD, the network time protocol date utility to make sure your date is in sync with the server side that you sync it with. So once you do that one, then everything is up to date. Let me just go back to the command line. And I believe on the, these are right here. If I just do a date command here, on the examples that I'm showing you on the website with date, if you want to change the date to some other date there, basically you need to have root privilege. But on the server side, there's something called NTP for NTP daemon. D for daemon. The network time protocol, I installed it this one, this way my date is always up to date accurate. So NTP Q minus P will just make sure that my system is there. The etc ntp.conf file is the actual servers that you're going to just sync your time protocols with their date and time calendar. So on the time of March, and then whenever that daytime light saving changes happen in March and in October, your date is going to be accurate. So when you do NTP by itself, I'm sorry, NTP Q by itself, you will get a list of commands here that are there. One of the commands is saying that show me the peers here, that you could get the peers. So if I just do NTP Q minus P for peers, automatically will show, and then you see the offset, everything is so accurate. So that means my date is there, that is accurate. And then you can also use other Unix commands to update your date commands along with the NTP protocols. And then so the date minus U, and then for update and pass on the NTP times and everything, you could sync it. But using this, and then if your root sudo sudash let me become root here. Must have typed it by mistake. So here, oh, sorry. This time it works, so it should be okay. So if I say NTPQ minus P, obviously is there because systemctl status NTP is running, NTP daemon is running. So if I just say NTP by itself, it just says this daemon is running, active. And then there's some process for it. The process ID number is there. There's let's go for LSOF, list of open files, and other commands that I'll show you there to say this is there. One of the command is pwdx. Remember we talked about pwd for print in working directory. You can just get a print working directory of a process. So in this case, 19966, this shows that it started from the root level. What this process, and then at this time I can stop my time protocols and start it and everything with NTP. But as long as it's running, you don't need to stop it. Your time and date will be in sync all the time, and that's what you need with the date command. So the examples that I showed you here, these are that when you want to manually change a date to a different date, you can change it. But every file that you create, the file has a timestamp. So like, for example, if I just create a file called new file, it doesn't exist here. Now I just say do ls-l and then send it to a new file. So now I just created new file. Notice that timestamp is based on the timestamp of November 1340, that was there. So this file is there, and if I just do a stat on it, which shows me the file, and the statistics of this one file is also showing in terms of the when was this file accessed, when it was modified, when it was changed, and the permissions, the user ID, group ID, all that information, the inode structure, all of that one is, this is a regular file because you can see there's a dash here. That's why it says regular file. If I just make a directory, make dir, say called new file, and then the file already exists because when you say a file could be a directory or a file. You cannot have a name for the file because in Unix and Linux, everything is file. So I have to say make dir file one. Now file one is there, but it does not make sense to say it's a directory and we call it this. So I'm going to say rm directory new file one, and then do ls-ld new dir one. For example, it's not there. I'm going to say make dir new dir one, and then now just up arrow this, and then that file is there. Notice this one, new dir one, is a directory and it has a D and this. So if I do a stat on the new dir one, you will see that this is a directory. And that's because of the first argument is a D here. And the permissions are done based on the UMask of the file. I'll cover those ones on intermediate and advanced chapters, but I'm just showing you the date and timestamp of the files. So star new, if I just want to see all the files that are new files, new dir and so on, that is there. Let's just do with the D, so it will show the new dir also here. And now the new file, it has this timestamp. I'm going to just say echo and then double gray sign new file. So now the new file content changed. Notice the timestamp of it was 1340. 1340 because I put one more line, and this time I do the same thing. Now it's 1342 rather than that. So here, if I do a stat on the new file, the timestamp changed. Notice that the modify got here updated, and saying that you updated this file at 1342. The original file was there created as 1340. So that's what the date commands. Let's see the next command, what we have here. Date and then echo. Echo you can do basically echo hello Wahid or echo Solaris Express. You just type in it, it will just do whatever you put in the string, it will echo it. So let me just demo it on the command line. So here, if I just say echo welcome to my MyWebUniversity.com, it will just echo that one. But if I want to just do new line characters after this, I could say -E for the echo to support these new line characters. And then at the same time say hello for this one. You can see that after the .com, I put a new line characters, and then it's did this. So I could just say echo -E and say hello, and then you could say hello and then a space welcome, and then let's say just I put a tab here, tab, and then say to, and then another tab, and then my web site, I just actually did the double quote there, and it moved it there. But notice that as soon as I press enter and went to this one, the site went to the next line. I could also do the same thing here, and then say our unix.com, and then say /new line and my webtutor.com and my webuniversity.com. These are all my websites, so you could just basically my webtut is actually my website, not mywebtutor.com. My webtut, which is for web tutoring. MyWebUniversity.com, it covers everything. Our Unix.com and MyWebUniversity.com, all my books, everything that I'm going to post, videos, everything will be posted on the MyWebUniversity. .com, and you could enjoy it. So that's what the echo does. And let's look at the next command. And the next command here is add. The head command, basically, whatever is the contents of the file, you could just read something from it. So words.c++, if I say word count minus L words.c++, this, .c++, so this file has 36 lines. So if I want to say, show me only 10 lines, I say head minus 10. Then, and that would display only 10 lines. And if I just use that -n option, the n is not supported there. But I could say cat minus n words, words.c++, and then that would be there. Then I say, give me head minus 10 lines of it. Now I have line numbers as well as this. And Unix, you have filtering. Filtering is the idea of like piping. And Dennis Ritchie and Ken Thompson, when they wrote it, they come up with piping in order to just eliminate reading larger files when they are having a very small footprint of memory. They have like 1 meg of memory, you cannot read 1 gigabyte file. So in order to do that one, they just basically introduce the idea of piping. So they could just say, cut content of this one, but I'm only interested on the first 5 lines. And then you could just get that one. And only if you are interested in 3, that includes the files there. The same thing, if you're just saying, I only do look for include, you could just get using the grep command. They wrote the grep command. And if you just say, no, I actually want a number of things, egrep. So they extended grep or egrep, expression grep, you could call it. It was written for the purpose of like searching for multiple things, cn and then cout. So inside here, I could do, show me all the include and then cout the statement there. And so there was no cn, so therefore it is not there. If I just want to say every function has a main, it will just display the main here, or every function has a return statement, search for return, then it will do that as well. So the piping is very, very accurate. So if I want to just only get the return functions here, notice that it only gave you 1 line. And then you could say, okay, that one is in line 35. And concept of, we were doing the head and tail. So while I'm on head, and tail is the opposite. So if you look at this one, say head of -1, it will give you the first 2 lines. At -2, 2 lines, head -1, 1 line. If you do the opposite, let's say tail of -2, and that would give you the tail of the last 2 lines. And then if you want the last 10 lines, obviously, it will display that. So head and tail is giving you based on the information. You can pass it into as argument, or you could say tail -2 words.c++ and then get those 2 lines. And then -10. You could just also, sometimes you want to get a combination of this. You could just say, give me, let's say, tail minus all the files, the entire file. You could just get this one, and then you say, from that one, only head -5, and then you just get that one. But you don't need that one if you just could just say something like this. Words.c++. So depend on your need. Sometimes there's different needs, different answers for it. So let's do the next one. We talked about that one, head, and then hostname. Hostname basically give you the host of the server. So in this case, if I'm just logged on the MyWebUniversity.com, and then the host name is there. Host ID is the hexadecimal value for that name. And then if you just say host name followed by MyWebUniversity.com, as long as you're the owner and then you know what you're doing, I mean, this is going to change the host name. You don't want to do that on a production machine. Because I know that the host name, MyWebUniversity.com, is accurate for the name. Whether I call it this or that, it's okay. So I could say host name now, and it says MyWebUniversity.com. But since I did it on my profile, I can change it back saying host name, MyWebUniversity, and then host name now is going to show that. So, and then host ID is just generated based on the host name, and then it's going to be accurate. So host name give you the name of the host that you're logged on current. On this machine, for example, I'm logged on algorithm, which is my Linux machine that I'm using here, and it's also Linux. So in this case, algorithm is, I named it based on the Al-Khwarizmi, the great Persian mathematician that his name actually was Al-Khwarizmi, and Muhammad bin Musa al-Khwarizmi. And basically, since he was the great Persian mathematician of 7th century, and back in Iraq, and now, and that area is maybe Tajikistan, I believe, but he was a Persian mathematician. So he was a great philosopher, great mathematician that came with the idea of algebra. And then nowadays we use algorithm, which came as a result of his name, basically. It was named after his name, Al-Khwarizm, algorithm or Al-Khwarizm. And was Al-Khwarizmi, changed to Al-Khwarizm, and Al-Khwarizm, and now we know it as algorithm. What is algorithm? Algorithm is basically a finite set of steps in order to do perform some computation and return some results. So for every task, you break it into subtasks, and then when you do a programming top design there, from a smaller subtask, you write a function, and that function have some algorithm, some set of steps to carry out the result and to return a value. Function always return a value. So to make a long story short, I named it algorithm, okay? So let's just go back to the next, sorry, the algorithm. Here you can see host name is algorithm here. And then the etc host file is also showing the name of the site that I just get, and then normally it is based on the IP address. And when you do an slookup algorithm, if this is on the DNS, it will report it, but if it is not locally it will find a local IP address on that subnet that I am. But this other one, that MyWebUniversity.com, is there. So if I say host name, NS lookup, name server lookup, www.mywebuniversity.com, you can see that is there. That returns an IP address for it. And that's the IP address on. You can also ping www.mywebuniversity.com, which is going to give you those connections. And that's saying that that host is alive. So let's just go to this information. Host is another command similar to the host name. So you can do the host and then get the host name there. And I'm showing you here examples of it, how you can just get similar to this host for google.com and so on. And then another one, ID. ID is a command that you could just, for example, like right here, I'm logged on this system, and I could say ID, and it just shows wlutfi. My user ID is wlutfi, my group ID, and so on. The UID is basically a numeric number, 1000, and the actual ID in characters is this wlutfi. So you can also do a man ID, and it will give you all these options. So and -G is for to get the group name, and then -N to get the name of it, and then A for ignore for compatibility, real time, and so on. So for ID -G, for example, it shows you the groups there. ID itself is going to give you that, and then I could also say get end password wlutfi, and then my ID is going to be also here on that 100. If this one is on the password file, I could say grep -I wlutfi etc password. There's also the user ID and password and home directory. All that information, my real name and everything is going to be there. So ID is here. ID-N will just say cannot print only formatted name. So that is not going to give you an option. Even though man ID just says when you do the -- name or N print instead of a number for UGS. So and sometimes it is sudo, you have to do dash and say sudo ID -name, let's say, and then say and it still did not, because that option, if I just do other options that are supported, it will work like -G. And then, so ID is just basically giving you your user ID and system identification. Info is the command that you can run like man pages. Info is basically info ID. It will just give you information on the ID command. And then you could just see that one has other examples also. So info PWD, it will give you info on PWD. And then info on info itself, give you info on info. It says that no page, but you can do man on info. So you can get information on this. The manual pages is also useful, like if you could say man -K by keyword info, then you can see there's so much on that command for man -K, let's say print F statement, if there's anything there, or sprintf statement, or fprintf statement, or man string there. So you can just get all these. Notice that the man pages, so I'm jumping back and forth on different commands. The man pages on section 3, so you can say man -S3 and then a string would be the same as just the command that I did up there. Or let's say scanf, you could see section 3. If you just don't do -S3 for section 3, automatically knows this is a section 3. So if I just say man -S3 PWD, it says no such command. But if I say man -S1 PWD, it will know that because that is under the section 1. So whether I type in -S1 PWD or don't type it, it will know, the system will know that where the manual page is for that command is. But info is to just get more information on the system, and I'm just showing you here some commands with systemctl and other ones. And then you can see the output of this command is displayed here on the system. This is like cut and paste command, so you can put some information from one file to another file. So let's say just make 2 columns of files. I'm going to just say echo this, and then say, actually, let's just say welcome, and then put this one to a file called T. Now the T has that welcome, and then now I say echo my web university, and then .com. So just if I just want to do 2 files, one of them is T and the other one F. there are times that you have these files in a big listing of them. I'm just generating those one column. You can do 10 columns the same way it works with paste command. So cat T is there, cat F is there, but if you want to just paste both of these two commands into a file called B for both, you could just say paste TF greater sign B. Now you just created a file B, and then the file B has both. Welcome MyWebUniversity.com. So now if I just do a cat minus E like before on B, and then and get also the A, notice that there's a $sign for the E option, but when I say show me all, there's a tab here. That's why this thing is, there's a tab here within this. So then I could just even use other commands later on from this B, and then if I just want to print only the first argument of it, print $1. This awk programming allow you to just say from the file B, only show me the first argument, welcome. If I want to see only two arguments, it's a argument number 2 is there. Similarly, if I just say ls minus ld, ls minus l star.c++, I have this list, and if I send this file to call the file T, now word count minus LT has a 70 lines, so more T, it has this file. Now if I just say cat T, and then I want to just only get these options, so I could say awk print and $1. And now $1 is there. And then if I want to just say $2 is that, $3 is that, and so on. So $9 would be their file name. You could just get this, and then you say this, and then say while read var do. If you just say you want to see the content of it, you could just say if $var and then I mean you could say something like is equal, and let's say words.c++. I believe that is there. You can compare that one, say then cat $var. You could say else ls minus ld $var. So either you just display them. The file there right here where I say done, I need to do a fi because I forgot the F statement I started. And notice that the command ran 100% accurately. And for every commands that I did, it displayed the command, a long listing of them as it shows. And then for the file that it found out, words.txt, and it displays it. So let's just take this line out. And this time we just want to say echo the date command. So, and then we need to put a semicolon here. And notice that programmatically, you could just say for all of them, and just you want to run date except this file. Programming is easy, it's fun, it's enjoyable. You're gonna like it. The more you learn, the better you become in the environment that you work on. So let's just look at the next command, the paste we did. And then examples are also here showing you. The PS command, PS is very powerful command. Shows you process commands here. I'm showing you process with user root, and that are outputted here, and then also show you the process 1, 2, 3. All the process 1 is, for example, system D, and then so on. All of those ones are scheduler, and then other ones. Like here, I'm just showing you ps-ef grep Apache, if Apache is running. So with the PS command, if I come back here on the command line, let's say on the part where I am on this MyWebUniversity.com. So ps-efa grep-i ntp, you can see there's a process. If I want to grep out my grep command -v grep, then only shows the last command. So clear the screen. I could do that, and or I could say, sorry, let me go back here. I could just say ps-ef grep-i http, or if there is no HTTP, Apache. So Apache is running, and you can see these processes for them there. And then you can just check on them. The arguments are there for this and related things. And then sometimes I could kill the processes if I want to do it by doing a while read var on the process ID number 2 and do this. For example, let's say you do this and you say awk print and $2, and then you could just say this. It will display all the process ID, and then put it into a while read var, and then say echo killing the $var process ID. If you do this one, and then, but I'm not going to actually do it, the command would be just, I'm going to put a pound in front of it so it doesn't execute, kill -9 $p var. So this would have executed. But I'm just going to say killing that command, and then at the end, when we do the ps-ef, those processes are there. See, so if I did not have this pound in front of it and I was logged on as root, it would have killed those processes. And then I would have to restart my Apache server. But I don't want to do it, so I put a pound here just to say that this would identify. Now, if I run my previous command here, you see those commands are there. If I just want to check on Apache HTTP, and then Apache, actually, it shows that those processes are there. The process ID did not change because I put a pound there. I did not kill it, or I did not restart it. So ps-ef is a very good command. And then I'm showing you a lot of options for them on the actual things that you can do with them. Let me go back to the website. So PS, we did a PWD. PWD is good. PWD, basically, if I'm just on, let's say on this one, here, clear the screen, PWD, it shows me I'm on the current directory. If I exit out of this, my PWD changed here, print working directory. There's also a echo $PWD, uppercase PWD, that is showing the current directory. So if I cd ... meaning that go to the parent directory, and then I'm covering cd and PWD in one command here. So when we get to the cd, we don't have to cover that one. And so cd ... PWD actually shows you that I am currently in this. Every time I cd ... mean go to the parent of that directory. And notice that echo $PWD is showing the current working directory. But if I just want to go to all the way from home to wlutfi to programs, I could just type in the full path of something. It will take me to that one, and then PWD will show where I am. Or I could just say relative to where I am, like right here, I'm on this directory, relative to that directory, move to directory down. So ... means take me back to C++ to the programs, and then all the way to my home directory in this case. And so the ... The cd ... current is just saying go to the current directory. So if I just do this one, and this is equivalent to cding home/w and this, or cd to tilde. It will take me to the same place where I am. But if I'm on the programs, and then I say cd to tilde, it is going to take me to my home directory. So that is equivalent to programs C++, sorry, programs and then C++. That is equivalent. If I do this tilde, it takes me to home PWD, or if I just do CD home wlotfi will take me the same place. So there's a physical path and there's a relative path. The relative path is from where you are and to where you get. And then a full path is the entire path. And then $echo is another environment variable that shows you the path of all the binaries and all the executables that you can run. At the same time, if you are just putting some path in there, it will go and search on this path first, say user local sbin, wherever on the binary that is in this directory will be executed first. And if there's another file similar to that one on this sbin and this bin, the one that on the sbin starts first because it's in the order of path is first. Same thing with the home PWD stuff. Echo $PWD, PWD, and all an uppercase. So PWD, and then that would do it. So if I just make a directory called test and then CD to test, now I just or and there, and then echo $PWD will just show that my current working directory. And then I go back here, I'm going to say rmdir test, it's gone. So let's look at the next command, pwd, we checked it, and uname. Uname has a lot of arguments, and I'm showing you here with a number of the arguments here. So you can do -a for all and get all the output, -m for machine type, and -n for node name, which is in this case MyWebUniversity, and then -m machine type, -r for revision, the build of the kernel, and then -i for platform information, and so on. So whether you run it here or you run it at the command, I'm just going to show a couple of them: uname -a, uname -n, uname -m, uname -p, uname -i, and so on. So uname -s for system. So you can get all those arguments outputs here. Let's go to the next command. By the way, these are basic Unix commands. On chapter 3, I'm covering intermediate. On chapter 4, I'm covering advanced. So less is just similar to page. It just displays the same kind of file, one page at a time. So if I say less words.c++, it just, you can see it's one page at a time displays it. And you can search it or type Q for quit. Less and page is a similar command, and I'm showing you how to put here that you can practice with it. ls is just give you a listing of command files similar to the command directory, and then ls -l give you a long listing, and then -l for uppercase for symbolic link and other ones, and -cfs for showing a file and directories, and then here star.html print $1. First, it just shows by inode number, -i meaning show me the inode number. Star.sh, and then these are the inode number of it. But because I'm printing $1 and $10, $1 is the inode number, $10 is the file name here. So here, if we run the same command on this command, here I could just go to var html, and then say this is the file ls -li to get the long listing with the inode number, and then say star.html, for example, and then say awk, and then print $1 and then comma $10. If $1 was the inode number and $10 would be the file name, it will just be displaying them exactly like we did here. And then since it is in long listing, with the first option, the argument, this one says ls minus l give you a long listing, I and the inode number, and then start.html would produce this, but we are printing only $1 and $2. And if we are printing more than that, then like $2, for example, whatever the $2 is pointing to, the read-write permission stuff, and then that will display too. Okay, so that is for ls. There's other options with ls. Do a man page on ls if you want to just learn more details of it. It will give you everything with all the syntax and some of the examples and everything. I covered enough for it, and I'm sure that if when you play around with it, you will find out more tricks and techniques that you could do, and you can set up aliases for yourself and everything. So what was the list? Man page. The man page basically is just give you the manual pages. So here I'm just giving you manual minus K for like a keyword on extended 4 file system. So then you can just get a list of them. And then similarly, if you do minus K for XFS, it will just do XFS and by itself, like systemctl command, you will see the actual Linux systemctl. And then the nice thing about systemctl is systemd. So if you do, let's say man systemctl, this is just basically all the daemons you can control it. That's why it's called system control. And then systemd is Red Hat and CentOS 7 and up. It replaced the system 5, which was init. Systemd is there, but all these options, systemd also replaced services. So instead of services, you use systemctl. And then you can disable daemons, enable it, start, stop, check status on it and everything. So like, for example, if I just say systemctl status /g for secure shell, I could just say that, okay, this is running, up and running. And I can configure them and there by enable it or disable it by default to run. So that's man pages on all of these. You can do it by keywords or this. And I already showed you the section 1 and section 2 and section 3. And now you check it with -s for section number. All the library files or functions or section 3 or section 2, and every UNIX commands are on section 1 mostly. Ls man make dir. So make dir, we did some example of make dir. I'm going to show you some more example here. Obviously, if you look here, I'm just showing some of the commands you can do. Make dir, you create a new directory, and if the 3-level directory you want to create, as long as you provide -p for the path, it will just create the subdirectories under it, no matter how many level you want to go. For example, if I say make dir new 1, new 2, new 3, new 4, new 5, this one will fail because I did not give the -p option. -p option, it creates it, and if now I do ls -ld, it will say that, yeah, this directory there, but if I just want to say, show me only this, it says this is 0 byte, but what if I want to see everything there, -r, and this one would say recursively. So the option of ls earlier when we were talking about, I did not mention the -uppercase R. So sometimes on certain files here, you could say ls -l C++, you could say that this is only showing one level. But if you want to see recursively the files and other directories that are there, like these other test directories that has this, you put the -uppercase R. So some of the subdirectory will also be shown here. Okay, so -R for recursively. And then -P for creating the path in there. And that directory. So there's a Linux command that is kind of dangerous. Okay, minus LTR. LTR is going to show you, like here under the C++, if I do ls minus LTR, it shows the last things that I worked on the bottom, minus LTR. T for the timestamp of it, but R for recursively, so it shows in reverse order. Minus L give me a long listing. So if I just say now cd to new one, and then new one has it, and new two, and so on. So, but I just don't want to delete this directly. If I say rm dir new 3, it just says directory is not empty. So now I say new 3, and then I say go ahead, delete this one, rm dir. Again, it's going to say directory not empty. And new dir 4, I cd to that one now, new 5. Now, since new 5 does not have anything, it's empty, 0 byte, I could say rm dir new 5. That would work. But now I'm sitting here on this, I could just say, rather than do on each one of these directories, if I want to delete 3 and 4 together, I could say rm minus rf new 3. New 3, meaning that the delete 3 as well as 4 recursively -r, F for forcing it. So this one took care of those ones. But I could have done the same thing with all of them together. So this new one has that one, and then new 2 is empty. I'm going to say rm minus rf new 1, and then now I don't have anything here. So I could have just done on all of them in one directory. So if I go back into my pwd command, I mean make dir minus p command right here, this command created all of them. So now I could just say find dot minus type d minus name new star new. If I just want to say do this and then list all of them that are directory, I don't have to say this, and then find out new. So the name does not match like that. I'm going to say find minus name star new star, and then that will give me everything. But I want to just do everything between 1 and 9-9. Notice that at this time I said, show me all the files that are, start with the word new and then this. So new one, all of this one, I could just do rm minus rf on them, or I could just say here, say, I don't need any of them, but in order for me to know for sure I don't need them, I say ls minus l d, give me a long listing of those files so I can see that I do need them or not. Yeah, new one, as you can see it, I don't need it. So there's an easy way than just doing that one. I could just this time say minus exec rm, and then I could just say rm minus rf and then there. But be very, 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 very careful on that -rf option, because you could inadvertently delete something that you don't want to delete. And then as a result, you see that I deleted everything that was on this directory. Now there's nothing in there. But you could inadvertently delete something, and that's why rm minus rf, you have to be 10 times checking, making sure this is a development, this is a testing environment, the name that you provide, you kind of validated that this is exactly what you want to delete, then you run that command and it's safe to do so. From time to time, you have to do something on the command line to just clean up on your trash or garbage that you no longer need it. But sometimes by accident, you could just say star.c, and then it might require or C++ or star.txt or star.sh. and it matches more than just one character. So run the ls-l command for it first to just check it, and then make sure that this is exactly what you need, and then do that. Make dir, and more is like less. So when we do more one at a page at a time, it is just like if you do here, say more words.c++, it's basically one page at a time. Similarly, page and similarly less is that. And you could just get kind of search for the options too. So when you do a more, like if you do more words.c++, you could say search for IO stream, let's say. And then if the search is in the bottom of the list, you could search for it. But if you already passed it, it may just not go there. Less words.c++, and then you say search IO stream, and it finds it. So if you just do while, and then it's going to find it, and cout is going to find it, and then you do n for a new, and then uppercase n to go backward, similar to vi when you search it. So less is your friend. More is very limited and lightweight, but less and cat and vim and other ones are more better, and a way to just do the same thing. What else we are doing here? More is done. Page, we are similar to more. Sometimes if your system doesn't do that page, if you like to type less, you can just create an alias for the page command for more. So like, for example, let's say here, if I just say page and then words.c++, and this says not found, I could say alias page is equal less. So now I say page words.c++, it will do the same. So yeah, some people, they install the software, some people, they just say, well, it's similar functionality, I need it, and I just do it. Ping is similar to like pinging to make sure that this site is up and running. So sometimes you want to say, well, is Google up and running because I'm stuck on something? So, or is my network working? So if I just say, well, I have netstat -rn, and I have this configuration, IPA, and I have my IP address configured. At this time, I want to say ping google.com. Is my network working? Yeah, actually, I can ping Google. So that means there. Can I ping IBM.com? Yes. Can I ping, let's say, jpl.nasa.gov? Yes. If it doesn't, and then most likely they're just for Echo 7, they're blocking to make sure that the distribution of denial of service attack is kind of there. But the www for the website is available pinging. So, and there are certain things like ping www.pasadena.edu will name or service unknown, Pasadena, sorry, Pasadena.edu. It is not pinging the main site. And then if I just do it, because sometimes through their firewall, they may be blocking it, as you can see here. But if I just go through HTTP protocol, then that would be responding, because if I just come here and say, okay, www.pasadena, then it will just respond. In this case, HTTPS for is what you have to check. On the NS lookup, pasadena.edu, you can see there's an IP address of this. And then if you try to ping that IP address, it will still do the same thing, because the host name was not allowing you, and then there's that IP address is actually through the firewall is blocking for the echo things. But if I just do like a wget or a curl or something, I might be able to get that, because that is going through a different port. Echo port 7 is for ping. So if I say, let's say curl that port, and then you can see that it comes in from the pasadena.edu, because this is curl is using HTTPS and HTTP. Pinging is there. And there's a file called etc services. And then if I say grep for echo from etc services, you can see echo is port 7. So port 7 for ping and other ones, or just sometimes blocked on certain firewalls. And if it is allowed, yes, you can do it. But if you're going through port HTTPS, that's port 443. So if I just go on this one, grep for 443, that port is, they're allowing it with HTTPS because it's there, 443 is there. And then the same thing with port 80, HTTP. So HTTP is, if I just look at it, port 80 is HTTP and 443 is HTTPS. And then there's other ports on this etc service as well, and that the system administrator could open it through IP tables or through firewall Ds or IPF W for, depending on whether they're running Sun microsystem, Red Hat, or older version of Red Hat with IP tables, or new version with firewall D or IPFW for Sun microsystem, IPF, and other stuff. So let's check it out with the next command. What was there aside from ping? Ping, host, and dig, and dig. That command also allow you to just basically run commands from, let me just make sure that I go to the, okay, so the MyWebUniversity here, I'm going to go back, I'm going to close this window and then just open this one so I have enough memory areas. Make there more is ping is the dig and dig. Dig, this command also allow you to just search on a website to get an IP address and a record of the IP address with this information. So when you do, for example, let's say here I'm going to clear the screen, say cat etc resolve.com file. So on this resolve.com file, there's a search name servers showing here. So I can say dig at this 127.0.0.53 and then go look for MyWebUniversity.com. So you can see that it shows the name server, and it shows the IP address, and it shows that it's a record. A record meaning that it's not CNAME like canonical name or something, is the main IP address for it. And this is the website host name. So when I do in this lookup, name server lookup of MyWebUniversity.com, also shows the same IP address here. But this one is a little bit more detailed with this. So in this lookup minus Q is equal MX, for example, shows MX record if there's any for mail exchanger, or minus QA for a record. Similarly, if I do that one for google.com, for example, google.com, you can see that a record is there. And then the MX record also, you can just get the MX record saying that how they route the mail exchanger in round robin. So the first maybe 100,000 mail goes to this server, then round robin to the 30, or started with 10 actually. So that's how their mail server works. The dig we covered, and we covered the next command is NSLOOKUP. NSLOOKUP basically is just similar to the dig command, we just covered it. So you can do a name server lookup of servers like NSLOOKUP of www.gpl.nasa.gov. Name server lookup of, let's say, alpha-live.gpl.nasa.gov. These are some of the services that I set up there. Let's see, we are not providing the details there. So, and let's see if we go to, and let's look up on IBM.com. And let's look up on Oracle.com. So everything, Amazon.com, so on. You could get the IP address of a name server like that. Basically, there's a kind of DNS names and domain name services on the etcresolve.com file of the particular host that is going to send this information to the DNS name servers, and from there it will determine where it's the .com, .edu, something, and from there it just goes to the next one. That's a different topic we will cover at a later date. So @rm, this is similar to cron jobs. @rm is running these commands, and you say @rm at now plus 1 minute. So if I want to run the command plus 1 minute, these commands, and then end of file terminator, it will execute the command pwd and ls-l 1 minute from now. Is there. @q is give you the job and listing, and I'm showing you here an output, and then the job number. @rm, based on the job number that is there, you just remove it, and then that way you don't wait 1 minute. But this command, similar to cron jobs, you can run as many as you want. And normally there's a @.allow and cron.allow and so on. All of those ones are configurable on the system based on what you want to do on your system and what kind of privilege you have. @q, we already covered. Sort is like sometimes you can get a file name and then reverse sort it and numerical -rn, and then sometimes you can just get the list, and then after you print it out like this one and those $, and then you sort it in numerical by the parameters that you want to sort it for. So sort is if you just don't give any argument, it just sorts it in the ascending order. -r would be descending order, and so on. So that is there. Touch command is just like creating files. So if you just make a file just by saying touch something, it will just create a file. Like here, say touch this. Now the file this got created. Touch that, whatever file I just created, that's there. rm this and that, both of them is gone. So touch also, if I have the file words.c++, you can also touch the words.c++, and now the content, the timestamp of that file, words.c++, the timestamp of that file become just now. So if I touch it one more time there, and then I do a listing, and now notice that the timestamp is basically only changes if you look at the detail of it on stat, not stat. So you can see that the timestamp of the file was there. So touch is a command also that you could do it when you're programming on large list of files, star.c++, and then you just want to run a make utility. The make utility sees that if this program was the only one that was touched, that was modified based on that timestamp, it only run and create the executable and the object files and everything all related to your make command syntax. It will just create those ones and run it based on the last file that was modified. If 10 of these the files were changed, and then it will automatically run those ones in the make utility. The make utility is very smart in that sense. So touch is just basically touching a file. If the file does not exist, like this does not exist, if I say touch this, it will create it, but notice it is a 0-byte file. If I just say ls-l greater sign this, now I created a file that is not 0-byte, and I just do a touch this. All it did this time, and the file is the same, the timestamp is changing because I did it at the same number of minutes, and this is same timestamp, but if a file exists long time ago, like let's say this file swap.c++ has that timestamp. If I say touch swap.c++ and do swap.c++, now it is November 27 rather than October 31st. So touch modify the timestamp of the date as well as create a new file if it doesn't exist with the size of 0. The W command we already covered is basically similar to the who command, and W-H for host name. Like you can see here I'm giving you some options. You can run the information and then -S. And then what else is there? -I. And then if you just want to get the syntax of them, please do a man W and then read the options there. See that the S for short name and then -H, no header information. I said host, but it's actually no header information. And then so on. So let's just do a system here. Clear my screen. I say W. That is giving you header, but if you W-H, no header. This load the average and everything is gone. So the W-S was the short name, and so on. So that's W, and then what else is there? That's who is the command is the last part of the who command that just runs the people that are logged on the system currently. Who -R also shows the run level. So if I just run it on my system here on this machine, clear my screen, say who, I just show that I am logged on. And who -R is the run level, meaning that this one is in, there are different run levels on Unix and Linux. On Linux, run level 0 is for shutting down, and just run level 1 is single user mode, run level 2 multi-user mode with network, and then run level 3 is multi-user run level 2 with NFS option, and then run level 4 is not used mostly. Run level 5 is in graphical interface, and run level 6 is for reboot, and run level 7 is also graphic interface with Xterm and everything available. But on the Solaris is different run level, -S, lowercase or uppercase, single user mode, as well as run level 1. Run level 0 and 5 is for shutting down on Solaris platforms, and then run level 5 on Solaris is if you have the hardware controlling the shutting down process. Run level 5 would also halt the system and shut down the entire system. So run level 1 and is single user mode, and then run level 6 is reboot, similarly to Linux, and run level 2 and 3 is similar to Linux, is for multi-user mode, and run level 3 is multi-user mode with NFS. And then run level 4 is not used on both of them. So, and that is the who command. And then with this, we completed chapter 2, the entire thing. So I'm going to post that video also here, so you could just enjoy practicing it on the site as well as watching the video. And then if you don't want to practice it, you could learn it first and then just come in and practice it. And if you don't want to practice on MyWebUniversity.com because you don't have internet access or a browser that you can play around with at some point, maybe your time is kind of not, availability is not there. So if it is not an option, that's fine. Just watch the video. All you have to do is learn it, and on your classes, you will be enjoying from this point on. And whenever you take a Unix course or a Linux course. At the same time, what I want to make sure that you are, if you're running a VM or a Linux server or a Linux workstation or anything, you could practice the same commands on and the examples that I was showing you on a SSH connection. SSH stands for secure connection, that I will show you on next chapters, some of these other ones. So the next video will be covering chapter 3. I'm just going to quickly give you a kind of like a glance at it. Chapter 3 is basically going to be talking about intermediate UNIX command. It's a little bit more advanced than the basic command on chapter 2. And then we will cover that one. Very easy commands, but again, you have to start learning them in steps. So we cover that one in chapter 4, which is a lot of commands, and a lot of them are advanced commands that you actually have to be really good by this time, maybe on at least on a junior level, to get good at these commands. If you're not a senior admin or a junior, you have to be at least a junior admin to learn these details. But again, nobody is an advanced person to begin with. Everybody starts from basic, move on to intermediate and then advanced. And you're welcome to start on an advanced if you feel like you can do it and learn it faster than normal people do. But it's your choice. Okay, have fun. Thank you so much. And I'm going to stop it. Please, when I post this one on YouTube or something, please make sure that you subscribe so you can just have the subsequent videos that I post, you can see them. Have a nice one. Take care. Bye.